Hi, welcome back.
And here we are. Good morning. Good morning, everyone. Let's start today's class. Uh, if you see into the chat, I have pasted the link of your Google Drive folder where you can drag and drop your homeworks. Okay, perfect. Everything looks like it is working. Then I will leave also the link that you find in this chat when I will save the video into the channel. I will leave the link in the description. So whenever you want, you will find the the link to upload your homeworks. And I'm trying to upload also previous files that I have done during this week. I don't know if I will be able to find them, but I will try. I mean, in order to have inside my channel all lessons that I was able to stream. Okay, and let me just remember uh, what you have to do as a homework, cause honestly I don't remember. So tell me which was your. I remember that I gave you 2 weeks to do it, but if you ask me which homework it was, I honestly don't remember. I remember that I gave you two choice. Probably was a coffee cup. Is it true? Yes, 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 yes. Exactly. A coffee cup, right. And is it true that I gave you 2 weeks or not? Because I'm not 100% sure. Yes, 2 weeks. Of course, Even if it wasn't true, you will say 2 weeks now. I mean, it's it's obvious. Um, so let's see. Let's see what we have to start discovering today. Um, Today in Inventor, we have to start. It is recorded. It's true. It's true. It is recorded. But where? Where is that file? Find it. If I find it, I will edit that part. I will change the audio and I will give you 1 week. Anyway, let's try being serious and let's see what we have to do today. That is, oh, I forgot my little app here. Epic Pen. Perfect. This one. Okay. So, what we have to do here is this. Today, we need to start talking about assemblies. There is this part of Inventor. Sorry if sometimes it looks like I'm stuck. Is that because down here in this there in here I have my second my telephone with the screen with your chat. So when I look down, is that because I'm reading your messages? Okay, I'm not falling asleep. And so what I was saying is this. Today we need to talk about assemblies and what it means. Assembly is very simple. When we need to create a, a an object, a design object that is made by mounting together different pieces, in Inventor, we need to make a realistic simulation, and what we have to do is, instead of making the object as one single block, like one single part, we need really to create all different pieces, and we need to make each in different piece that is at the end is combined into a final object. We need to make those files as parts. But then, when we want to check if all pieces together are perfectly working and they snap each other, they are not like having interference and so on and so on, then we need to combine them all. And the way that Inventor offers in order to let us combine different parts is called assembly. So, first of all, it's important to understand that we can't create an assembly from scratch. An assembly by itself, it's simply a group of different parts. So, first time that we have to use assembly, and first things that we will do today will be we will start by having to design two or three small parts. I will show you how to correctly save them, and I will show you then how to use them inside an assembly. And into our assembly, I will show you how to check if these parts can be really attached together. And in order to make like a to-do list, look, if I am right, I have this software here, uh, this one, board, exactly. So, this is yesterday. Yes, let's see, how can I delete it? Yes, make a new one, whatever. Perfect. And this is our to-do list. That is, we need today to make three, I will say, small inventor parts. And this is important because, as I said, an assembly is basically a container where we can put our parts inside, and then we can check if these parts are matching each other. So we need basically to start understanding how our parts have to work together and which is the relationship that they have. So just to let you understand which files I'm going to create, what I will do is I will make here a very simple sketch so that uh, we can understand, I mean, what we are going to see in Inventor. So I will make three very simple parts at the beginning, and they will be made like this. Look, I will make just one starting simple box. Then I will make something that is slight. Wait. What's that? I will make something that is slightly more complex. That will be this object here. And last but not least, then I will delete that yellow thing. Don't ask me why it's there. And then I will make a third small block. And let me see if I can make a new. Sorry. Let's delete this. Okay. 1 second. Let's do it like that. Okay. So I was saying this. We will make one box to start. Then we will make an L-shaped object like this. And then I will make a smaller box. This is why. Simply because the final result that I want to obtain must be something where these parts will be snapped together, and the relationship between my last object will be this object must precisely instead being snapped here. So at the end I will have my object number 1 perfectly attached to my object number 2 perfectly attached to my object number 3. So at the end, this is how my final Inventor assembly should look like. In order to make this happening, I need to create this, this, and this object as a different Inventor file. And I will basically have to create really 3 parts that I will simply call part number 1, part number 2, and part number 3. So I will really save these as 3 independent files. And also, what I like to explain, especially if you are starting Inventor and you have never used it before, when you start making different projects, it will be a lot better to create independent folders for each project. So I will make, let's say, let's call it school folder. Inside this school folder, I will find all these parts. When I make another project, I will make another folder and I will separate the parts into independent folders. And later on, I will explain why this is so important. But first thing first is, let's start by creating our parts in Inventor. So I start by clicking New Part, and as I said at the beginning, this will be that part that will be just a regular but slightly big box. And I need from now to start using Inventor with a bit more precision. I need to start using it by knowing dimensions, by adding parameters, so not just by drawing free things, like weird things without dimensioning and so on and so on. So let's start by making first box. So I make, for example, from the top, that is XZ, I will start making a sketch, and I will start by drawing a rectangle. And once that I make my rectangle, I will start adding precise dimensions. This is extremely important because I need, when I make parts, I need to have an idea of what I'm doing. So I need to start writing a few notes, remembering dimensions, so that my pieces will start by being matching parts. And the more numbers I write, the more numbers you will see sketching here. So look, let's say I set that the distance, so I add my first dimension to the rectangle, that is from here to here, and then I click there. Let's start by writing simple numbers that we can remember. So this will be 20 millimeters large. And then I will add a second dimension. Let's say this will be 30 millimeters. So just by remembering, my first box there is this one. This will be 20 millimeters by 30 millimeters, so that I start sketching a few elements. Then I click Finish the sketch. And with this sketch, I will use Extrude to make it three-dimensional, and just by using simple numbers and by remembering what I'm doing, I will use as a height, I will use 40. In this way, my first box will be 20 by 30, and the height will be 40. So that, I mean, it is pretty easy to be remembered. And let's say, till here, nothing new. But let's start viewing how to save this file so that it will be easier to reuse it. I will click Save, but basically, when I click Save, Inventor uses always latest folder that I have used in order to save my file. What I will do instead, what I will do instead will be, I go, let's say, to the desktop, and I start by clicking this symbol here, that is make a new folder, and once that I have done this, I will call this new folder School, as I said. Wait a second. And I will double click inside, and oops, screen is gone. It's back. Don't worry. Okay. And as I was saying, I save these as a part 1, just to remember that this is my first file. And this is number 1. And I get this. Okay? And once that I've made these, I will close part number 1, and I will make a new part. I'm using these simply because I can show you piece of papers or I have not a whiteboard, but I'm remembering this simple sketch so that I remember easily which kind of dimensions I have to use for my next part. My next part must be the L-shaped element that I said. So I will start this time, because it is easier to make an L-shaped, I will start by drawing the L shape that I will extrude. And you will see something that I do on purpose, that I will do, that is, instead of drawing directly the L on a vertical plane that can look a little bit more logic, I will draw all my parts starting into the top plane. But just to show you then how interesting is the assembly process in Inventor. So look, again, I select the top plane and I draw an L-shaped object. So I start without any dimension, at least when I draw, I try to have a little bit of attention, and I try to make my lines straight. So when I see the symbol perpendicular and parallel, that means that I'm fine. And then I will start adding dimensions. So this distance, the distance between top and lower, must match the height of my part number 1. So this will be 40. Then all other dimensions can be whatever. I will just use simple dimensions just to have to deal with no complex numbers. So I will make 20. I will make this distance 20. And I need to fix this distance. Let's say this will be, I don't know, 10. And then I need this one. Exactly. No, that is not needed because I have this already. So this is fine. And what I have to do is I will write here these dimensions just to remember. So I change the color and I start by drawing this L shape. That is 40. This down here is 30. This is 20. This is 10. This is 20. So this will be 20. And we have our phenomenal sketch. Then I finish this part, and the depth of this extrusion is the one that needs to match the value of my previous object, that is 30. So when I click extrude, the extrusion will be 30 millimeters, so that if I finish the sketch of my three-dimensional part, that is like that, this dimension here is 30. And I can save my file. And as you can see, because I have created my new folder and my last file has been saved in that specific folder, you can see that Inventor immediately opens that particular path. And if I click save, I will save into the school project folder. I have almost done. I need to make my third part. I will just remember you that I have to make a smaller box that has to fit this gap. So this box must be a box that will be 10 by 30 as a depth, and it will be 20 as height. So I close this, I make a new part. I will start from the top, sorry. Again, I start by making a simple sketch. So I make a rectangle, and I will give this rectangle 10 and 30 as dimensions, and then I will extrude it 20 millimeters up. So I will give this dimension, and look, I'm doing on purpose something that is slightly wrong, but I'm still using correct dimensions. But I make these 30, then I make this dimension 10, so that in floor plan it matches dimensions that I need. Then I extrude it, and I extrude it 20 millimeters. And this is my last phenomenal piece. I click Save, and I will call it Part 3. Then you can give your files, and this will be when your project becomes a lot more complex. It will be a lot better to give your files more precise names, like with the functions that they have, with the orientation, like left, right, top, bottom, cover, lid, handle. I mean, you should give your files names that you can highly and easily recognize. So, let's close our last file, and let's also delete these sketches that were useful just to understand dimensions that we have to maintain along the process of making our parts. So now we are ready to create our first assembly. And how to do this? What we have to do is, I mean, this is, I know, will be a little bit shocking, but if we want to create an assembly, we need to make assembly. Ooh, believable. And what is phenomenal here is that now you have just an empty object. And you can also see that basically most of my tools are even turned off because right now there is nothing to do. Simply because when we create an assembly, what we have to do is we need to start by going in this area and take care we don't have to immediately click this big button. Don't do it. What we have to do instead is we have to click down here where it is written place from the content center, but most important here we can see that there is a small triangle. So it means that there is another tool that we have to use. So I will click down here, and I will use the tool that is simply called place. When I do also this process once, so when I click place, I also change which is my default action in this top area, so it should remain just place. But what it means place? Place simply means that I can browse my computer and I can bring a part that I have already saved in my folder, but I can bring that part inside my assembly. And this is exactly what I'm going to do. So I browse the folder that is called school, where I see these three parts, and I will start by clicking part 1, and I click open. And This will be at the beginning a semi-transparent preview. So I just left click and I have placed my first part. What you see also is that Inventor is giving me the possibility to continuing placing part 1, but we will see this later on when we will make examples with more parts. So when I will show you another interesting example. So for now, once that we have clicked once to place our part 1, we press escape from the keyboard. And we simply repeat the process of placing. But as I said before, you can notice that now our main button will remain with the option that is place. So we can just click it. We will select part number 2. Click open. And we place our part inside this area without any precision, without any snap. We just left click it. And that's it. I mean, we have nothing else to do. We need one repetition of part number 2 and we press escape. Last but not least will be we repeat this process for part number 3. Select the part, click open, place it, and we just need one repetition of this. We can press escape and we are good to go. So what we have now, if you see now, we have our 3 elements that should be attached together, but basically this is like having 3 construction blocks laid on the table. So what we have to do now is like having instructions to follow, and we must combine these pieces together. So what we have to do in order to combine these pieces together, as we have sketched, let's see if the sketch is still there, should be here, exactly. Our sketch must be like this. So this is our final result. We need to have that basically, yes, that this face here, the top face, front face of these 3 objects must be perfectly aligned. Then we need to discover, we need to see that top face must be aligned, and so on and so on. So we need to combine these objects by basically applying these rules to our pieces. So let's understand this. Technically, this face this one and this face, so the one that is on this side, they need to perfectly match. They need to be aligned. Then we need to make other adjustments. So when our piece will be mounted, this top face should instead be align it with this top face. And last but not least, this face of this object must match that face of my part number one. So these are rules that I need to check if they work, and if they work, my pieces will perfectly snap together. But how can I how can I check if this is true, and how can I apply constraint rules to my parts that I've made in Inventor? This is exactly what you have to do into the assembly. And into the assembly, this tool here, and I will highlight it even more, the tool that is called Constraint is the one that allows you to start creating matches in between all of your single parts. And this is what we are going to do now, immediately. That is this. Look, I click Constraint, and this is the dialog box that appears when I click Constraint. And what I have to see is that into Constraint I have, first of all, in here, slightly different ways to create relationships between different parts. The one that we will use the most will be this method here that is called mate, and this basically allows us to align planes together. And when we use mate in combination with these, we have these two options. And we will see them, we will explore them in a second. And how constraint works, because this is very interesting, is basically we click constraint. Then we click one starting plane or face, call it as you wish, of your object. And once that we have clicked first face, we move our mouse and we click second face that is on the opposite, on another object, that in this case is the opposite face. But we click here, and what Inventor does will be it will match these faces together. So look, if I click my second face in here, this is what happens. Poof! And if you have also speakers turn it on, when you make these, you also see a sound that makes like poof. Okay? If we are happy with the result, we click OK. And let's see what we have created in Inventor, because this will start by being unbelievable. Look, if we try by selecting now an object, let's say like this box here, and we left click and drag, we can see that we are free to move this box wherever we want. Okay? This box has no constraint. We haven't yet matched this box with any of our parts. So if I move it, this goes wherever we want. But now, check this instead. We have created our first relationship. So we have said to Inventor that this face of this box must match this face of this L-shaped object. So now, look, if I move, so if I left click and I select this box, it looks like I can move it wherever I want. And I can do the same here. But it is not a 100% free movement, because if you rotate your point of view, you will see that no matter where I try to move these pieces, now this is just super far, but my plane, is a little bit too far, exactly, but my planes are always matching, because I have created one matching constraint. In Inventor, believe it or not, in order to lock parts together, you need to create 3 relationships between 2 parts. So basically, why 3 and not 4 and not 2? Simply because into the space we have 3 axes, we have 3 degrees of freedom. There are movement or rotation and so on and so on. So in order to lock 2 parts to become one joined element, we need to lock the movement on the X, the movement on the Y, and the movement on the Z. Now I have created one constraint only, so these objects are still able to move, but at least that face remains matching. So what I need to do is simply, I need to keep making constraint. But now, let's see this. What I need to do now is, I want to match top face of this L-shaped object with the top face, that should be this one that now is looking forward, of this box. So where is the difference, and why? I showed you before that we need to understand these 2 options here, this one and this one. Simply because when I have made the connection between these 2 faces, look, one face was looking like that, second face was looking like these, so they were opposite facing faces. And if I want to match opposite facing faces, I need to use this option here. Now, because I want instead this face that is facing up and this face that is oriented forward, I want both faces to be matching, but I want them to remain like that. So I want both looking at the same direction. So in this case, I have not to use this option here, that is the one that is called mate, but the one that is called flush. So I need both faces to have same level. So I will first click flush. Now I can click this face and this face. I left click. Boom! And now they are perfectly matching. So they are looking at same exact direction. And I can click OK. And if you check, now if you try to move one of these objects, this is what happens. Look, I can slide this box only along this direction, as well as this L-shaped. But if I try to drag these objects left or right, because they are sticked together with constraints that I have created before, now one object drags the other one. Okay? You can still see that I have one last degree of freedom. That is, these objects can simply slide up and down. And I will fix these, so I will check if everything works properly by creating a third and last constraint in between these two elements. And what I will do will be simply I select constraint. Take care, I want this top face and this top face to be oriented on the same direction, so they must be flush, not opposite. So I click first that I want the relationship to be flush, and I click this second option here. Then I click first and second plane. Boom! And I have perfectly connected these two objects. And now, if I click OK, I can also see that now, no matter which part I move, which part I select of these two, they are perfectly attached together. Okay? Till here? Let me know. Does it work? Let me see. Messages. Perfect. Okay. So let's see another thing that is something weird that happens into your assemblies when you create them. Can you see that when you now we have sticked these two pieces together, they also look like one block only, and it is hard to discover which is object number one, which is object number two. This is only, and don't ask me why, something that happens by default when you start by creating an assembly. So if you just want to see your objects a little bit better, and you want to see exactly where edges are, something that I simply suggest to do is in your assembly file, you can go into the menu that is here, that is called View, and you can change this parameter here, the one that is called Visual Style, and simply if you need to see exactly where your surfaces and edges of your objects are, you click Visual Style, and instead of using shaded, you use shaded with edges, like that. In this way, you will see exactly all of your surfaces, and as well as that, you see exactly where all edges of your objects are. This is not only because I suggest, but simply because when we create relationships, so if I go back to Assemble and I go to Constraint, we will see the more we make complex parts that we are not limited in creating matching relationships between planes, but we can create also relationships between edges, circles, certain loops, and so on and so on. So understanding better how your geometry is created will help you also in creating your final assembly. But now, just to repeat another time these concepts, now we need to check if our last block will match these, this space in here. So I have to make other 3 constraints. So I will start by understanding this. I want this face and this face. This face is looking like this. This face is oriented like that. So I don't want them to be flush. I want them to be mate. So I want them to match. So I have to click Constraint. Mate is always selected by default as a matching option, so I'm sure that is there. I click this, I click that, boom! And first object that I click is the one that is moved. Second click that I do is where my first object goes. So I can click OK, and now I can try. And each time that you make a constraint, you can try this. That is, you can try now to move your object, and you can see that you are still able to move it back and forth, up and down. But if you rotate your point of view, you will see that even if it looks like this plane, this plane is perfectly matching. And now we have just to add more connections, more constraints. So we need to make 3 of them. So for example, I can say that this face, this one, must match the one that is here. So I can click Constraint. I will click Mate, and I select. I want to move this little box, so first that I click is the face on the box. Second, I click the face on my L-shaped solid. Boom! And I click OK. And now my box is there. The only movement that it can do, if you try, is you left click, you drag it, and you will see that this thing now can only slide up and down. But I can't move it on the left, on the back, on the forth. No, because if I shift these, now that I have created constraints, now they are stuck together and they are perfectly working as a one element. But I can still move it up and down. So I have to make my last operation. So I click Constraint. This time I want that this face and this face must be flush, so they look up together. So what I do is I first click that I want a flush constraint, and then first object that I click is the one that moves, so I will click this. Then I click that. Boom! I can click OK. And now I can see that starting from 3 different parts, I was able to create a final assembly. Okay? Does it work? Let's see. Let's see your messages. Perfect. Okay. Let's see this question. Let me read it. There is, Marco, could you show how to do, for example, a door hinge constraint? No, no. My dad said I can't. No, I'm sorry. So, let's see how to make a door hinge. That is, I mean, it's too easy. It is too easy. So, what we have to do? First of all, sorry if I move. Making a hinge is not as complex. It just requires a little bit of preparation. So, first of all, let me see if I can, if the screen goes black for a second, don't freak out, okay? I just need to see if I can have my pen working again. Let me see. Because, no, where is the pen? Give me 3 seconds. I just need to see this. No, the pen doesn't work because I wanted to make better sketches. So, as I said, don't freak out if the screen goes black. No, it's okay. So doesn't matter. Let's prepare the sketch for the hinge. I mean, I'm so sorry. I don't know why the pen stopped working. But basically, what we need to do. And this will be also an interesting process because I will show you not only how to make a hinge, but I will show you um, something more that is inside the assembly property. So what I need to make hinge, I need this piece. Look, yes, this one, and why is not drawing? Hmm. No, but this is everything against me. So let's draw it here. Look, I need one piece that will be like that. And that will have a hole. Then what I need is I will place a cylinder that has also a stop here and then continues like that, so that these will be the axes of my hinge. But in order to make it more realistic, I will need another piece down here. Of course, they will have same radius. I'm just sketching them in a very poor way. So that these will be the hinges. So these two pieces will be able to rotate around that center part. So the hinge will perfectly work. But why I want to make the hinge like this? Basically because in my sketch you will notice then that this part and this part are exactly the same. And this is not secondary because when I make assembly, um, if I have a an object that is made by 10 pieces, but if 8 of these pieces are exactly the same, I don't have to make one file each part, but I can instead just make one element and I can put the same exact element inside my assembly as many times that I need. So let's create these two parts because I need to create only this element and I need to create this element here. So I need part number 1 and part number 2. Look. So let's close my assembly. For now, yes. For now, yes. So let's create those two parts. And again, because we are here to learn, you will see that I will probably make one mistake on purpose. And later you will see which one. So let's start by making not the cylinder part. Let's start by making second part. So there is actually first, sorry. So I just make this. Look, I make a rectangle. I make a circle in here. Exactly. Then I start giving a few dimensions. So I make these, I don't know, 10 millimeters. I make these 40. No. Yes, 40 millimeters. I make this circle diameter 30 millimeters. Perfect. Then we need to create the hole inside. So I make an offset and I make this offset 10. No, 10, yes, 5. No, let's keep it 10, it's okay. We have almost done. This now, it is a shape that can't be extruded at all because it has these intersections. So what I have to do first is I have to click trim and I have to trim these unnecessary parts. Okay? Then I can finish the sketch. By making these, I can now click extrude. I will click the inside of this object and I will extrude how much? 30. Fantastic. Believable. Okay? Ready for this? What I do now is I save these. I'm using school as a folder, but if I start by calling automatically this part like part number 4, then it becomes a little bit complex to understand what I'm doing with this part. So I will call these hinge top and bottom, and you will understand in a second why I've called this file hinge top and bottom. So I should remember a few parameters, and at least I have to remember radiuses that I was using. So let me open the sketch. So the diameter is 30 and this offset is 10. So it means that if I measure this radius, the radius is 5. Okay. And I make a new part. That would be cylindrical part inside my hinge. I can do it in multiple ways because, just to let you remember, the object that I want to obtain must be something that actually works like this, where this diameter must be 30, this diameter must be 10, this height is 30 as well. This height doesn't matter, could be whatever, we will make it 5. So, if I want to make this piece, now let's make a poll. Let's see. If I want to make this object, which tool you will use? First one who answers correctly will have D at the end of the semester. Let me see. If you don't answer, I forgot to say, if you don't answer, you'll get F at the end of the semester. So at least is better than D. Let me see your answers. Which tool you will use if you want to make this object? Let's increase loft. I forgot to say, who answer wrong will be bumped. Ay, 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 ay. We have 2 winners. There are my 2 lovely students who have, yes, now it's easy to say revolve, but revolve written with capital letters and is correct, is revolve, because I can simply, let me change the color, I can simply draw this profile, put a center line in here, and if I use revolve, this will immediately becomes my solid. If I use loft, just to answer and to see why I'm not using loft. If I use loft, these will be smoothed together as curves. So the result, if I make these 4 circles, will be this. Also, if I want to use loft, it will take forever because I have to make a plane here, drawing 1 circle. A plane here, drawing another circle. Plane here, and again. As Edward said, circle and extrude. Again, why I'm not using even that? Extrude both sides. No, same kind of annoying problem, because I have to make a circle, extrude it once. Then on top of these, I have to make a circle and extrude it. But this will take more steps, more sketches, that it translates also in, if I make 1 mistake, I can possibly make 1 or 2 mistakes more. So, no, so sorry. Right option is only revolve. So, I make a sketch. I draw this sketch, and I close it, and also top and bottom parts of this sketch are symmetrical, so I can also use a few interesting features, like I can use parametric dimensioning, like this must be 5, and this, because final diameter is 30, this must be 15. Then this, we said, doesn't matter, but we just make it 5 millimeters. And last thing that we need to say is how tall is this part. And this should be 30. And just in case I have to press escape, and this dimension, if I double click, is called D3. So if this is 30, I also want that this and this is equal to D3. So it would be exactly the same up and down. I have almost done. I will simply draw this line. That for me is my revolve axis. But in order to tell Inventor that that is an axis, so it is not part of my solid, I will select these, and once that I select it, I have to click this as center line, like that. So it becomes blue, blue because it's selected, but it becomes dash dotted, and for Inventor that means it is an axis. Okay? So I can finish the sketch, and if I click revolve, boom, immediately in one tool only, I will check that I was able to create this beautiful part. Okay? And I will call this, I will save it, and I will call this hinge center. So that is the part that remains into the center of my hinge, of course, and I save it. I can close it. So that now I can make a new assembly. When I make my new assembly, just to check a few things, I can see this. Look, only because in this current session of using Inventor, I haven't used place from content center, I can see that here I see place immediately. If I go to view, by the way, I can see that by default, whenever I create a new assembly, my visual style starts always by being shaded. But I need, and especially now, because I want to see my round edges, I need to see where round edges are. I have to click visual style and I have to change it in shaded with edges. So we have almost done. I can go back to assemble, and now I can place my component, and we will see these things. I click place. I will start by using hinge center, and I will place it somewhere. Okay? And I press escape because I need one of this thing only. Ready for this? Because this would be unbelievable. Now, I need to click place. And I will use hinge top and bottom. And what I will do is I will click open, and because I need two of them, I don't need to create two equal files, but I simply need to left click once to place one Hinge element. But you can see that because place is still working, I can place another repetition of this by simply making a left click. And if I need more, I can simply keep left clicking, and I will simply add more and more of same exact piece. But when I have enough, I press escape. So this is a 3 pieces assembly that in reality is made by 2 files. So what you can notice is, first of all, you can notice here that into the assembly we have our objects displayed by their name, and simply next to each object there is a number. So I can see that I'm using the hinge center, but I'm using only one hinge center piece, while I'm using 1 and 2 repetitions of the piece that is called hinge top and bottom. Okay? So, see this now. Now we need to create constraints in between these objects. So, what I will do is I have first to find right orientation, and you will see me doing something that is a little bit complex, but something that you need to pay attention. That is this. Look at these two pieces, this one, this one. They right now have same exact orientation. So this face here is this face here. And when I make my assemblies, I need to correctly place my objects, and you will see this in a few minutes. But why I want you to focus the attention here. Look. First thing that I will do is I will click Constraint. I want the hinge piece to move, so I will click this as a first plane, and then these must slide over this plane of the center part. They must be mate because one will look down, one will look up. So my second plane will be this. Okay, and now this is more or less what I want to do, but this is working. Before going on, what I will do is I will also repeat the process with this second piece, but this time this face that I see in my screen must match this lower face in here. So I click Constraint. I want to move the hinge, so hinge is first object that I click, and second I click the part in my center part. Boom! And I click OK. Okay? Now I have almost done. I need simply to tell that this object and this object should have their rotation axis perfectly matching. So what I will do now is simply this. I select Constraint. But now what I do is, instead of selecting a flat face, I will select this part. So I move my mouse inside the hole of top top piece of my hinge, and you can see that when I move the mouse on something that is round, Inventor allows me to select the axis of this rotation. But take care, because I'm not moving my mouse on the edge. I'm moving my mouse over round face of my hinge. So I click that, and after this click, I also repeat the process again by moving my mouse on the round face of my center part, and I left click it. Okay? But you can see that because now I am using axes, the constraint solution is offering me completely different options that are opposed, aligned, undirected. So I have to select first one and just check if it works. So I click OK, and this, as you may see, doesn't work. So it is constraint, this axis, and probably I have to select second one that is aligned, and you can see that this is the one that it works, simply because my arrows of the two axes were both pointing up, and I can click OK. So now, see what I have obtained. Basically now I have that first and second element are not 100% constrained, because I was able to create two constraints only that are the axis and a face. So this piece can't be moved, but due to the fact that it is a round object, I can still rotate it. I need to finish my hinge by matching lower axis. So look, constraint. This is the object that I want to move. So I select it first. This is the one that I want to match. And you can see that this time the opposite option was working, because my hinge center axis was showing me the arrow that you can see here. It was pointing up. The hinge piece instead has the arrow that was pointing down. So unfortunately this is a matter of try if you don't see those arrows immediately. But sometimes you have to use opposed, sometimes aligned. Forget this. But now I have selected right constraints, so I can see that this object can rotate, but I can't separate these pieces. They are one hinge. Okay? Till here? Because now I want to show you one more thing now that we have this hinge created. Can you limit the rotation? Ha! Ah, technically, yes. Let me read the message. Can you limit the rotation? Uh, Technically, yes, but yes. You can, but not today, because if not, we will go too much in depth in one specific feature. So I will show you this next week. Not next week, because then I have a big announcement. But yes, technically you can, but not today, because if not, it would be too complex. While I need to show you another important thing that is more important for assemblies. That is this. Look, I save my assembly. Let's say I call it Hinge, and before one believably important thing that you need to know is that the assembly itself is a file that is simply linking these parts together. This is extremely important to understand, because if you do something to your original parts and then you reopen the assembly, you will see changes in your assembly immediately done. What it means? Look, if I close the assembly and I open the folder, that is this one, that is school, and I open Hinge top and bottom. So I open original part. And if I change something in this piece, like, let me do just two random adjustments. Let's say I chamfer this, and I fillet this, and again radius 5. So I make my part a little bit more interesting, so I make it more beautiful, and I save it. Okay, I've just clicked save. When I reopen the assembly, that is something that I've created before, see what happens. It says that my files has been changed, so you want to update, you click yes, boom, and you immediately see, let me also change the visual style, but you will immediately see that your hinge has that parts that have been updated and that has been changed. So can you also understand why, when I have used constraint, I haven't used the top face and the top face stick it to the center part, but I've used bottom and the opposite face, so that my assembly will show me a symmetric result. So in this way, for example, I can save yes. I can open again my hinge, and let's say here, I can select this plane. I can start making a sketch from here to there. Let's say finish. And I can extrude these. It was 2.5 millimeters, so that I add this small part, and I can save it. Then again, I open my assembly, that is the Hinge. It will say that my files have been changed, so I have to update, and you will see this immediately changing in my assembly. And now this is how my Hinge looks like. This process of creating assemblies in Inventor is extremely important because you need to understand that it can be like a work in progress. So your pieces doesn't have to be immediately precise from the beginning, but you can make a rough piece, make a test assembly, and then you can start refining your objects, and you can work in each individual part in order to make your precise assembly at the end. And last thing that I need to tell you, that is why you need to understand that the assembly is an empty file that contains only the link, sorry, only the link to your parts, is because if you do something just to your files, so not even with Inventor, but if you how can I explain? If you simply, rename now one of these files. So let's use my previous, the one that is called assembly, and the one that I've called part 1, part 2, part 3. If they make no sense, and I have this brilliant idea, that is, I rename my files, like I call it big part, I call this one L-shaped, and then, and then I open the assembly. This would be a drama, because what happens is that the Inventor is not finding or the file that was linked into the assembly, and it basically says skip, and unfortunately my assembly will be empty, so it will have those missing elements. So let me see questions. Can I replace one piece with another? This is a tricky question. Technically yes, but logically I would say no, because technically what happens is that if you do something like a trick into the files, like if I rename this object part 1 and then this part 2, in this way I'm making a trick into my assembly, because I can replace parts just by changing their names, but in reality, basically Inventor finds that they are not like original files. And why? Because they have not similar planes that they have before. It finds that they have not same how can I say, same dimensions in bytes and so on and so on. So at a first, the answer will be no. What instead? So let's skip them all. Skip all. So unfortunately, what you have to do is, let's say Control Z, Control Z. If you want, instead, you can put a piece. Then, if you want to replace, let me tell you, easier thing that you should do is you simply select, you hit delete, and unfortunately, you put another piece. I mean, especially at the beginning, this would be better way to work with different pieces. Okay? So just 2 seconds, because then I have to make right now another class. Is this what you want to do next week? Continue with assemblies, or what I will prefer, make your midterm test. Let's vote. So question is, and I'm waiting the answer, vote assemblies. Oh, these are answers that I like. I'm okay. What you prefer? Okay. Assemblies. No, wrong. Because it's always first answers that are winning answers. So next week we will do a midterm. The midterm, of course, won't be like a 3ds Max one that I will give you only 2 hours. I will be 2 hours live, so it would be preferred that you make it during the live. I will basically give you two small parts to be done, and I will ask you to save the parts and make a simple assembly with the things that I've explained today. Nothing critical, nothing complex, something where the part modeling will be the core of the test, and then you will save the file. But because I'm too good, I will start live streaming and I will give you instructions for the test. You will do it during the 2 hours of the time. If you can finish it in the 2 hours, you will upload it, I mean, in those 2 hours. If not, I will basically leave the midterm folder available for 24 hours. So if you are not watching then the video live, or you are not you're not in Italy, so you can't watch the live stream at the same time. Yes, would be the same for me as well. Edward asked, no, if you want, I can give you a much harder one. It's okay. I will give you, let's say, one or two choices, and you can choose according to the difficulty level. Is it okay? Lovely. Perfect. So this is it for today. Let me let me save this file on the channel, so that then I have to start my AutoCAD class next week. So be prepared, charge your batteries, have your mouse, and because we will do a beautiful test. Okay? Yes. Bye, everyone. It has been a pleasure, but the stream stops now.